This video is about solving linear equations using a graphing calculator. So sometimes when we solve for a variable, our answers do not work out to a reducible fraction, or they do not work out to a nice integer. So instead, we're going to use a graphing calculator to help us solve. So when we're using a graphing calculator, all rounding should be to the nearest hundredth, which means 2 decimal places. So remember, anytime that we are doing rounding on a calculator, it's your nearest hundredth or 2 decimal places. So step 1 is to look at your first equation, and you're going to call the y1 whatever's on the left side of the equal sign, and whatever's on the right side of the equal sign, y2. You're going to graph, and then find the intersection. So before we start graphing, looking at our calculator, we have y equals up here at the top by the screen, the window button, zoom, trace, and graph. Hit zoom 6 to make sure that your window is reset, and then hit second mode to get back to the original screen. So number 1, what we're going to do first is we're going to split it into our 2 equations. So without solving or simplifying, all we're going to do is write down our y1 and y2 equation. So y1 is anything to the left of the equal sign. So 10 times parentheses 2 minus x plus 4x. y2 is negative 3/10 parenthesis x plus 3. So in our calculator, we're all going to go to y equals, and we're going to enter the equations in. Type them the exact way that you see them written or that you copy down. So y1, we're going to type 10 parenthesis 2 minus x. To get the x button, it's next to the alpha key, or on a diagonal from the second key. So 2x, close parenthesis, plus 4x. Then arrow down to your y2. Notice that y2 has a fraction in it. So because it has a fraction, you need to use parentheses with it. So we're going to do parentheses, negative 3/10. So we use the negative sign down at the bottom. 3 divide by 10, close parenthesis, and then parenthesis x plus 3, close parenthesis. Once you've entered your equations and you've double checked that they're the same that I have, hit graph, which is the top further right button. Hit graph. Some of you might have a color, some of you might not, so your lines might look a little different. If you have a color, you might see different color lines instead. They're all the same thing, they're all the same picture. Okay, before we start doing our solving, we need to draw ourselves a picture. So to draw a picture is just a rough sketch. So here's one line. Make sure you're always putting arrows to show that your line goes on forever in both directions. And then I have my other line. And I have my intersection point. To find the intersection point, we are going to hit second trace. Trace was the button next to graph. We want to calculate the intersection, so we want to hit 5, option 5. It'll take us back to our calculator and start asking you first curve, second curve. So first curve, just use your arrow until you see a blinking cursor. So I'm going to keep hitting it. Now I finally see it at the top, so I know it's on one of my lines. I hit enter. The next one is on my second line right here, so I hit enter. When it says guess, move it close to the intersection. Doesn't have to be right on it, but somewhere close to it. Hit enter again, and then it'll say intersection. This is our point of intersection. So on the graph, we're going to label it. Remember, we're rounding, so 3.66. The third number is also a 6, which means we round up to 3.67, and our y value is negative 2. Then because we're solving for x, notice that all of our equations have x in them. We only want the x value to solve. So x equals 3.7. Now, while this one fit in the window and we could find our intersection, sometimes we have to adjust the window. So if we look at our graph and we see it's going to the right, but it's off of our screen, this means that we need to adjust by changing our x max in the window. If we want to go to the left, we need to change our x min. So we're moving along the x axis. So to the right would be x max, to the left would be x min. If we want to go higher, now we're moving along the y-axis. So to go higher would be your y max, and to go lower would be your y min. To go back to the standard window, we're just going to hit zoom 6. So let's try a problem where we have to change our window a bit. So when I split my equation in number 2, I have 4/3 parentheses x minus 8 and 1/2 parentheses x plus 5. So I'm going to go back to y equals and hit clear for both equations and type in my new equation. So the first equation is parentheses 4 divided by 3 parentheses x minus 8. And my other equation is parentheses 1/2 and parentheses x plus 5. Graph. Now I see my lines, but I notice they don't intersect. So I need to kind of look at, well, where are they getting closer? They're getting closer somewhere over here, which means I need to move to the right and maybe up a little bit. So I'm going to hit window. And I need to change my x max because I want to see more of the right. So instead of 10, I need a bigger number. So I'm going to try 25. Y max, I'm not sure if I need to change it to see a little bit higher or not. So we're going to change it anyways to 15 and see if we're good now. So we're going to hit graph. Okay, now we can see our intersection. So I'm going to draw a picture sketching out my graph. So I have one line coming across this way, arrows. One line coming across this way, arrows. Here's my intersection. Okay, so to find your intersection, second trace, 5, enter, enter. We can move it closer for our guess if we want. Enter. And it gives us our intersection is 15.8, comma 10.4. So my x value then is 15.8. Now let's look at what happens with our special case graphs. So we want to hit zoom 6 to reset our window since we changed it. And then we can exit out of it. And let's look at number 3. So number 3, we're going to split into two equations. So my first equation is -2 parentheses 3x plus 4. And my y2 is -6x plus 5. So in my y equations, I'm going to clear out what I have. I'm going to type y1, -2 parentheses 3x plus 4, close parenthesis. My second equation, -6x plus 5. And I'm going to graph. Something special happens in this one, though. So when I graph, notice that I have two lines, and they look like they're running at the same slant, which means they're never going to touch because these are actually parallel lines. So when I have parallel lines, lines that I can tell are never going to touch, they never seem to be getting closer in this picture. Even if I change the window, they're still not going to be intersecting because they have the same slope of the line. So these are parallel lines. This is one of our special cases. This is when x is a no solution. So anytime you see parallel lines, this is a no solution. Let's look at one more example. So I need to split my equations. So my first equation is 2/3 parentheses 6x minus 9. And my second equation is 5x minus 6 minus x. I don't need to hit zoom 6 because I left my window the same. So I'm going to go to y equals and clear out my equations. So y1, parentheses 2 divided by 3, and then parentheses 6x minus 9, close parentheses. My second equation, 5x minus 6 minus x. Hit graph. Notice this time, I only have one line that shows up on my graph. This is actually the other special case where there's really two lines, and if you have a color calculator, you can kind of see that the colors are overlapping. So this happens when lines are overlapping. This is our other special case we talked about with solving. So if you have overlapping lines, this means x is equal to infinitely many solutions. Or we can just say infinitely many.